Welcome. In this video I'm going to show you how you can perform an exact multinomial test of goodness of fit using Microsoft Excel. I'm using Microsoft Excel 2019, but this should also hopefully work in some of the previous versions and hopefully also in the next versions. This will be focused on how to actually perform the test, not so much if you should perform the test or interpret the results. It's all about how to actually calculate it. So I have my data in column A. It's only a few rows because this is going to be computational heavy. And the first step to do is create a frequency table of each of my categories. So I typed in Diemen, Haarlem and Rotterdam, and then I used a function countIf. This counts how often in column A the value that I typed in over here in F9 actually occurred. I'm using a semicolon Excel version where you use to separate parameters a semicolon. You might be needing a comma for that. I then also summed this up. So the sum function, so in this case I have a grand total of 10 cases. The expected probability, in my case that's simply going to be 1 over 3 for each because I have 3 categories, and in this case I'm just going to assume that each of the categories was equally likely to be chosen. Next I set the number of categories, which I've done by using a count A over here, and then the total number of combinations that will be possible. So this will be 10 plus 1 because an option would also be 0, and then raised to the power of the number of categories. After that we're going to determine all possible combinations, or perhaps I should say permutations, of picking k times a value between 0 and our sample size, so in this case 10. So what I need is I need to mimic like these 10 people with repetition. How can I distribute them over these 3 categories? And I need to list every possible combination. And to do that I'm actually going to do that for every possible combination of 10 people or less. So 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 2, 0, 1, 5, etc. So that was a little bit tricky to do, but eventually I managed, and that's what's being done over here. First I have my first category number is 1, and then I can simply copy paste this formula to the side if I needed to. This simply checks if the cell next to it is empty. If so, it just remains empty, and otherwise it will increase it by 1 if it checks if I would add 1 if it becomes if it's smaller than or less than my number of categories that's in there. If that's the case, it just adds 1, and otherwise it just shows a blank. So that way I can copy paste that to the right, and oh, I haven't actually done that. I can copy paste it here, and that nicely gives me 3. Now to list all the possible combinations, here's a long formula. This uses the row number. It first checks if my row number minus 2, because I have these 2 on top, if that's greater than my total number of combinations, then it can just report a blank. And otherwise, if this value, if the category number is less than or equal to the number of categories, then I actually start doing the whole calculation and of this, and otherwise I'm actually not going to do anything. So I could put actually a semicolon of empty in there as well, like this, but I'm not going to. Anyway, so if so, then what it will actually do is it calculates the module of a round down version of the number of rows minus 2 minus 1, so minus 3 in total, divided by my number of options plus 1 because of the 0, and raises that to the number of categories minus which category or column we're actually looking at. It's going to round it down to 0, and then the divisor will simply be the total number of options that we have plus 1 again, and that should give you a nice, and I can copy paste this to the side, and I can copy paste this all the way down, just as many as I need. So I can check, I will need 1331, so hopefully if I scroll all the way down I've done it at least till, yeah, and the last one is plus 2 because the first 2 rows, so that's why I'm ending at 1333. The last one should be indeed 10 10 10. So these are all possible combinations. Alright, once I have those, I can also copy paste my probabilities here. This actually checks the probabilities from here. You might have to adjust that for yourself, and you can just copy paste that to the side. Alright, that was the hard formula to do. And copy it to the side. Yeah, we've done that. So we actually don't need all of them. We can add the expected proportions in O1. Yeah, we've done that, and now we eliminate the unneeded combinations. So from all these combinations that I have here now, looking at all this, I actually don't need all of them. I only need the ones where if I would sum these 3, it should match my total sample size of 10. So that's where this formula comes in. If it's empty, then it shouldn't be doing anything, and otherwise it should check if the sum of those is equal to my sum of the frequencies, and if it is so, put a 1, otherwise a 0. Right, I can copy paste this down because I've set the dollar signs appropriately, and this takes a little while, might almost crash, let's hope not. And uh-oh. Alright, now it's done. So as you can see, here is a 1 because indeed the sum is 10. You might want to put a nice border here on the right hand side because it's slightly different than the other ones. So only those with a 1, and then finally we can start calculating probabilities. The next thing is determine the multinomial probability density function for the different combinations. Now that one is a bit tricky to calculate, but it can be done. There is a function, so this just checks if we should be calculating it, only if there's a 1 in here. There is a multinomial function within Microsoft Excel, so that's useful, and we can use the explicit frequencies that we have in our row here, but then we need to multiply that with these, and each of these needs to be so we need to multiply them with the expected probabilities. Those are there, actually up here, sorry, but each of these needs to be to the power of whatever the values are in the frequencies for this particular row. Now by using a logarithm function, the sum product, and then the e function, exponent, we can actually do this. So also this formula is up here. You can copy paste that all the way down, and it should give you the correct results. Last thing is then that we only want those where it's less than or equal to the observed version. So the observed version is that same function, but then just using the one over here, the values. And the last thing is then sum all of these in column M if they are less than the one that we observed. So we can use a sum if column M, and the criteria is less than or equal to what we have over there. And then we finally have our probability value of 0.6265831, which is above 0.05, so most people would consider this not significant. So it could be that in the population each category will be chosen equally likely. We don't have enough evidence to reject the null assumption. I also made a VBA macro that can actually create this function, and that does the same steps and calculates everything in one go for you. If you're interested, I'll upload this Excel file on my website, for which there's a link in the description below. Hope this was helpful, and thank you for watching.